Hello everyone, welcome back to Nexus VLSI. So till now we have learned the basics of Verilog. We have seen the introduction where the major part is synthesis versus simulation, what exactly it is, then the abstraction levels in Verilog, then what is difference in Verilog from other traditional programming languages. Then we have seen the basics of Verilogs, the syntax of Verilog, then some of the white spaces, characters, line characters in Verilog, escape characters, escape sequences. Then we have seen how we are going to write numbers in Verilog. We have also seen how we are going to write comments in Verilog. Then we have seen what exactly is a module in Verilog. This one is very important. This is the second video in which we have covered all these things. It's very much important if you see that video. In this we have seen how a code is being converted into a design, how we have developed a half adder using the code. We have developed a full adder using two half adders, and we have seen how we can include sub modules to create a bigger module. So today what we are going to learn is we will be learning the data types. What are the data types used in Verilog? This one is very important because in any language data types are the one which creates the base for that particular language. So what are the values a particular data type in Verilog can have? Any variable in Verilog can have four values. These four values, that is 0, 1, unknown, and high impedance. I hope you know all these values if you have studied digital or you are having a simple knowledge of digital. But let me explain you further also. If you are having a wave like this, 0 and 1 depends on the reference you have taken. It's a 0, it's a -5 volt, it's a +5 volt. If you have configured your +5 volt as you'll treat it as one logic, and if you have configured you'll treat your -5 volt as logic 0. So simply by saying 0, that doesn't mean that it is a 0 volt. There is no voltage, right? Like over here in our case it is denoting -5 volt, and 1 will be denoting what over here is +5 volt. X means the design doesn't know what the output will be. It might be 0, it might be 1, right? This is a confusion. The design don't know. It can be 0, it can be 1. And what Z is, it means high impedance. If we are having two connections, A and B, 2 points, and between these points this wave is flowing, what high impedance means is between A and B there is a high resistance is incorporated. So in simple wire terms you understand is, but over here we have the impedance, right? What exactly is impedance is, you can search it on Google. What is the difference between a resistance and impedance? This I have given you to just have an idea, to get a explanation, understanding of this. So some current might pass over there through this particular resistance. That's why you are seeing this bar is between somewhere between 0 and 1. So moving ahead, there are majorly two types of data types in Verilog. One is nets and one is regs. So over the time you will be dealing with the code, majorly you will be using these two data types only, nets and regs. So what exactly a net data type is? Net data type is nothing. You simply think of two components, component A and component B, or 2 points and a simple wire connecting them in between. This is a simple wire which is connecting points A and point B. So this is nothing. This is only simple what? A net or a wire. Why I am saying it as a net or a wire? Meanwhile, in next upcoming 5 minutes, you will get this thing clear. So if it is a simple connection of wire, what happens is it simply represents a physical connection between hardware elements. A and B are our two hardware elements. A and B were our two hardware elements, and it is a simple connection between them. It is continuously driven by a signal or a value. That means if A is being driven by some value, it will be visible at point B, and the point and the time you removed this particular value, you removed this driving this A, you removed this connection, what happens at B will also stop receiving the values. you will not receive any output. What you will receive in that case? The default value of net is high impedance, that is Z you will receive. And if it is sending the value whatever it is receiving, that means it is not storing any value. A wire doesn't store a charge, right? It doesn't stores any memory. So moving ahead, this is our one type, that is net type. Second type is our net type. So in net type, understand it like this: you are having A and B connection, but over in A you are having some memory. This memory is storing some value. That means reg is a type of variable. A is of reg type, that means A can store some value. If you have applied a connection, you have populated some value, let us say 0 or 1 over here, and you have removed this connection. So what will happen? This 0 or 1 will retain. But in our case of wire, if we have removed the connection, the value was not retaining. So reg will do is it stores the value. It actually acts as a memory cell. It acts as a memory cell which holds its current value until and unless a new value is not assigned to it, right? The default value of reg is unknown. Now you might be thinking that if it is storing the previous value, it might be a flip-flop, it might be a register, it might be a memory. It happens, but not each and every time it happens that a reg is always converted in design into a register, flip-flop or memory. It is based on the code you have written. Sometimes what might have happen is whatever the design you want to achieve, and you have code written, and in that you have used the reg, but according to simulator that particular design can be achieved using a simple combinational logic. So in that case it will not create a memory element, right? Next we will be deep diving more in the nets. So in net, let us say we want to develop a AND gate and you want to connect it to inputs and outputs. So in this case you are having a AND gate and you want to connect it to input and output. You have A and you have B. So these inputs you want as simple wires and the output as simple wire. So how you are going to declare it? You'll simply use this keyword wire, A, B, Y. So that means it has declared 3 wires, A, B, Y. Now what it means? It has simply declared the wires like this, A, B, Y. Now you have to connect these wires. So how you are going to connect? Remember this thing, in whenever you are using a wire, it should be a continuous assignment. That means whatever you are assigning at the inputs, it will be right at the moment visible at the output. So majorly it develops what is combination logics. So what happens is when you do write this statement, assign y equal to A and B, at that particular point what it will do is, you are having 3 wires A, B, C. What it will do is A and B, it will do AND of these 2 wires and it will assign it to what? It is Y. It will assign it to Y. So that means it will assign it to Y. So the 2 inputs are being AND and assigned to Y. So this is how your wires are being used. Now if you cut off the supply from A and B, there will be nothing at output Y, and the default value is Z you will receive of wire. Nets are also bifurcated in some of the categories. The majorly which type of net which you will be using 99% of the times in your codes is wire. So this is the major one. Wire means what? A simple wire connection between point A and B. Then the second one is try. Let us say you are having a wire A and B, and at the time only one driver is applying a signal over here, means only one person is driving this particular input. So a wire is sufficient. Let us say what happens if 2 to 3 particular inputs are driving this particular point. So in that case you use try to manage among all these inputs, right? For example, tri-state buses we have seen. Then we have W and try and. W and try and will do what is, they will you are having a point A, you are having a point B. To point A there are W and try and will implement what is, it will implement a simple AND logic. What a AND logic it is, if you are having 0 1, it will provide the output as 0. If you are having 1 0, again 0. If you are having 1 1, it will provide 1. And if you are having 0 0, it will give 0. So what will happen if A is being driven by two signals 0 and 1, so what it will drive at the output is 1 or 0. It simply drives 0. So in this case, if multiple signals are there, that means you'll use try and. Similar the case of W OR and try OR. It is a simple OR logic at the input, and if it is multiple drivers driving the same input, it will be try OR if you want to implement the OR logic. Then there comes a special case, try reg. This try reg is what? It can store a charge as a capacitive storage. When in your design you want a capacitive storage, what you use is you use try reg. So what happens in try reg is, if you are having a point A, you are having a point B. At point A, you have defined point A as try reg type. That means A is of capacitive type. Now what happens is, you have applied some input, so what it will store that particular charge, like let's say 0, and at output immediate you will be seeing 0, and now you have removed the input. So what happens is, at the output you will still see 0. Instead of high impedance, you will see this 0 output. Now you might be wondering that why try reg is being placed under nets. It might have placed under our reg. The difference over here is, see, this is the difference. This in design, it will be visible as a capacitive storage, which is a type of combinational. So what reg will do is, reg will properly take care of the memory as a sequential circuits, right? So moving ahead, in case of reg, what happens over here is, if you are having the same design, now you want A and B to be of some type of memory elements. You want to store the charge. Whenever you remove the supply from A and B, you don't want Y to be something which have high impedance. You want it to have some values. So what you have defined A and B as, you have simply used a keyword reg A comma B. Then you have defined Y as a wire that you want the immediate output of A and B. So whenever you are going to apply input at A and B, you'll receive the output at Y. But what if in this case it is reg, so it is storing the previous value over here in these elements. So if you have removed the supply at both the cases, there will be still output at Y based on the previous values. Now this one bifurcation is for reg. Reg is actually belonging to a bigger type of data type family, which is registered data types. So reg is one of the part of registered data types. So reg is having the default value unknown. This reg is the one which you will be using throughout the coding. It is the main one. So it is of 1 bit. The values reg can have is 0, 1, unknown, and high impedance. Then comes our second registered data type, that is integer. By default it is having 0 value. It is a 32-bit signed integer. That means it can have from -22 to the power 31 to 2 to the power 31 minus 1. It can have range. So it can be like 0, 1, 2, 3, 4, -46, -146, +256, -256, -251, +251, right? It is basically used in loops or counters. You might be designing some counters in your design. Over there you simply use integer instead of again and again designing flip-flops and connecting them, right? So these reg and integer are synthesizable. What exactly synthesizable is, I have explained this thing in detail in the very first introductory video. You can go over there and watch that. If you haven't watched that video, prefer watching that first, so that in that case only you will understand what synthesizable is and what non-synthesizable is. This one is the very basic and important thing in Verilog. If you want to design circuits, you have to know what synthesizable and non-synthesizable is. Then we have the real data type, then time data type, and real time data type. All these three are non-synthesizable. Real means the floating type numbers, the real numbers, 0 0.1, 0 0.2, 0 0.3, like that. Then we have the time, it is a 64-bit unsigned. What time it is? It stores the simulation time. Means you might be having a series of flip-flops which might be having some delays in between them. Let us say at the very first flip-flop you have started as 0 simulation time, that means 0 seconds, and after there is one delay in each flip-flop, so after 5 flip-flops you will be at 5-second delay. So if you use $time at the very first flip-flop, it will give you the output as 0 seconds, and if you use this $time at after 5 flip-flops, you will see as 5 seconds output. That means $time will give you the exact current simulation time on which stage you are. Real time is what? It stored time as a floating point number, means 0.1 second, 0.2 nanoseconds, 0.3 nanoseconds, 0.4 nanoseconds, like that. Then we are having regs and nets can be mixed together. This one is a note, remember this. That means if you are having two variables, wire a, reg b, you can assign b to a, that means a reg to a wire you can assign, and if you are having b assigned by a, that means a wire can be assigned to a reg. So this one video was very important for someone who is looking to deep dive in Verilog. This one was a in detail depth video of the data type of nets and reg. People usually have a confusion in them, but after seeing this video your confusion will be removed. So I hope you like the video. Moving ahead, what we will be learning is we'll be learning the vectors, how the memories are designed in Verilog, how arrays are designed in Verilog, what arrays are, what strings are. All these will be moving ahead and we'll be learning it day by day. So keep watching, keep learning, keep continuing, keep growing, keep supporting. Thank you.